Hi everyone, and as you can see, the abbreviation MUST is kind of a very good phrase when you want to say to someone you must calculate the measurement uncertainty, so it is quite catchy. And it is the abbreviation for the measurement uncertainty service tool, actually. So let's get more into detail. Many of you maybe know the measurement uncertainty term, but what is it and why do we need it? It's a kind of the big part after you do the validation job and after you have your measurement method, you have to calculate the measurement uncertainty. It is because the true value is in fact unknown. Every time when you measure something, for example, a length with the ruler, for example, you know that your ruler has a specific uncertainty. It has a standard deviation or something. So it is not the true value, but it's also a measurement. This measurement value is an estimate which is influenced by a specific type and factor. And the uncertainty is also a parameter which is associated with the result of a measurement and is also characterized by the variance, which is contributed by the specific measurement parameter. And why do we need it? In fact, it is also a customer request, but in terms of OSH, it is for legal regulation. When you want to compare your limit of quantification to your OELVs, for example, you have to consider your measurement uncertainty. And also when you want to have accreditation, as in ISO 17025, or when you want to compare your lab with other laboratories, and also when you want to improve your measurement method, you should consider the measurement uncertainty. So there are many standards, regulations, and sources for measurement uncertainty. There are percentages, there are many requirements, basic information for workplace air especially, and nobody knows how to calculate it, and everybody does it just as they know how to do it, but there's no guideline, no big part where which you can use, and then you have a result in the end, which everybody is happy in the end. So we decided to do a tool, to develop a service tool where you can calculate the measurement uncertainty with a user-friendly interface based on the first headlined guide, which is the Uncertainty of Measurement Part 3, the Guide to Expression of Uncertainty in Measurement, which is also called GUM. It is, I would say, the holy book of measurement uncertainty, and this is why we decided to use it. So there are many basic requirements for the measurement uncertainty, and it all bases on the minimum measurement range, which was also mentioned before today. We have in Germany the risk-based limit values and also the health-based limit values with 0.1 to 2 times the limit value, or 0.2 times AK, the acceptable risk, to 2 times the tolerable risk. And this is the minimum measurement range of your method, depending on the limit value. And when you have these measurement ranges, you have different types of expanded measurement uncertainty requirements, ranging from 30 to 50%, depending on which range you are in. So that means when you want to calculate measurement uncertainty and you have your range, you have to calculate on 3 points of your range the measurement uncertainty, at low point, at midpoint, and at the high point, high concentration. So you have to do 3 measurements basically and 3 calculations. And we thought about which terms or which parameters and influencing factors you have to consider when you want to calculate the measurement uncertainty, basically everything which is inside your measurement method. So there are 4 big parts which you can see here in this diagram. It is sampling, it is sample transport and storage, it is volume measurement if it is necessary in terms of metals, for example, and also the analysis. Firstly, the big 3 parts mentioned, sampling, transport, and volume. These, there are already some percentages or some guidelines inside the norms. You can use these values. And for the analysis, you have to use your validation data. For the calibration and also for the recovery, and as my colleague told you before, you also should consider humidity and temperature if necessary. You should also consider this, and you can consider your validation data in the software itself. And I will show you now how we wanted to do it. So this is a snapshot of our software here on the right-hand side, and we wanted to have a very user-friendly interface for everyone. So nobody has to do maths, nobody wants to do statistics. So we do the work for you. We thought about not just our institute wants to use it, but also you want to use it. And so I'm doing the advertisement for this now. So we also decided to have a language switch from from German to English, as you can see in the right side in the top, and you can see here the first sheet of the software, which is the fundamentals. You can see here that we have in this first window on the left the basic information. These fields and drop-down menus are just for documentation purposes. That means that you can type in your operator, your OELV, the validation data, and the application which we're doing during your validation process. And we have default values, but you're also able to use free text, so you can also use your own data for it, not just our data. So the app applications which we have placed here, it's the aerosol generator, the dynamic guest stream. Oh, it's it's difficult. Spiking, loading, and also you have at the bottom the free text. So this is the first window, and more important, you have the information on the procedure, you have the process, which is basically the 3 different types of methods. This software includes 3 different types so far. We also are where we want to enhance and expand this tool for more measurement methods. So right now we do have thermodesorption, we have metals with ICP-MS, and also the extraction methods. So depending on which method you choose here, you have to consider different windows or these different boxes here at the bottom. You have for extraction or thermodesorption, you have the left window here, and for the metals with ICP-MS, you have the right window to consider and to fill in the blanket or to choose from the drop-down menus. I don't have the time to show you all details from all the methods, but I can assure you we put very tremendous effort inside it. And when you want to have more information, just contact us or use the user manual. It is quite big, and we thought about to use every information we could find how it is to use. So let's switch to the more important sheet, which is basically the calculation sheet. Firstly, you have to provide your data. You can see here different buttons. You have the Get Data button, firstly. So that means that you can load your validation data via an Excel sheet directly into the software. And when any error is occurring during the read process, you can also show the error messages so you can see which problem did occur. As a second part, you can type in your validated concentration. As I told you before, you have these measurement ranges. You have the lowest, the mid, and the high concentration. And for these concentrations, you type in here the validated concentration on the top. And then you type in the flow rate and the sampling duration, and if applicable, also the digestion volume, and click Calculate. And when you do that, the software automatically lists on the right-hand side the influence factors and gives you the result at the bottom. It also depends on the method which you choose, but it is also calculated without any further calculations which have to be done by you. When you are done with the calculation, you can also save the calculations and all the data which is displayed here using the Save button, and then an Excel file is created which is also showing your results. You have here all influence factors. I also don't have the time to go further into details, but you can see here in the columns the name of the influence factor, the uncertainty, it's the calculated uncertainty, the sensitivity coefficient, and the relative contribution of each parameter to the relative uncertainty. Then you have the result of the calculation, which is better. It is the calculated concentration, which we also heard by my colleague Christina before. It's the mixture of, or the quotient of mass and volume, milligram per cubic meter. And this is also done with regard to the systematic influence factors. You have the combined standard uncertainty and also the expanded measurement uncertainty. And this is what you want to get in the end. This is your result in the end, and with this you can work. But before you trust this value, you have to consider 2 more sheets, the recovery and the calibration sheet. This is where you can check which data was put into the app and if everything happens well. So firstly, at the top, you can see the source where your data for the recovery comes from. And since we calculate the measurement uncertainty for the recovery based on a regression model, we have also regression coefficients. And at the bottom, you can see the measurement values which were also read by the software itself, which is the target concentration and also the calculated concentrations of your validation. Same for the calibration. You have the calibration data with the target value and up to 3 different sets of calibration data, calibration curves, and also the regression coefficients. When everything is fine here, you can switch to the model data sheet. This is also done by us beforehand for each method, a new model data sheet. And here you can see the name of the parameter. You can see the value with respect to the sensitivity coefficient in this column here. You can see here the description of the parameter and here the percentage which you can gather in the ISO standards or just your calibration certificates. And also, if you have questions, please read the manual or ask me. It's complicated, but we try to figure out anything. So to conclude, how can you get this software? It is, we just finished it after, I think, 3 years of work, and it can be downloaded. Must is an .exe file, so everyone can use it having Windows PC, and it is available at the IFA website for free. It is open source, and we checked it for viruses because we don't want to download few viruses. So the download is quite big with 2.5 gigabyte because it creates a runtime environment for MATLAB in the background. Our statistic god at the IFA created and programmed this app, so it's quite big, but it is worth it. The folder includes also the data sheets for the validation data, where you can type in your own validation data to create your own model. And the user manual in German and English will follow at the end of September. It's not available right now, but we're just at the finish line, so please wait for some more weeks. And also the software is not available right now, but it will at the end of September or hopefully next week. And in the meantime, if you want to ask questions, help, support, everything, or just when something is not working and functioning, please contact us at this email address at must@dguv.de. Please don't hesitate to download it and give us feedback. We were really happy if you would use it. Thank you.